and I'll show several in the next few slides. This particular creature is remarkable in many ways. It's so-called naked mole rat, which lives in colonies in tunnels underground. They live much longer than most other rodents. Mice and rats tend to live 3-4 years at the most. This lives at least 32 years. It's highly resistant to cancer. Scientists sometimes do nasty things to the creatures in their labs that would ordinarily cause outbreaks of cancer or outbreaks of osteoarthritis. But when scientists do these things to these creatures, there is no disease. Remarkable. And people have figured out what the likely mechanism is. The flexible skin that these creatures developed in order for them to go quickly through tunnels is achieved by means of something called hyaluronic acid, which most people haven't heard of, but it's a component not of our cells, but of the matrix between our cells, the extracellular matrix, the scaffolding that holds the whole cells together. And this particular animal has a different form of this compound. I'll just call it HA for short. The chains are longer than in most other animals, and it also has greater quantities of this acid than most other animals. So scientists, on discovering this, started asking themselves, are there other creatures that also have such a hyaluronic acid? Let's look at slide 13. When indeed there is such a creature, it's a particular breed of dog, the Shar-Pei dog, which was bred over many centuries in China. It was not bred because the dog breeders thought we'll give it hyaluronic acid. It was bred because they selected the dogs which had most skin folds, which some humans like to see. But as it turns out, such dogs do have the long chain of HA and have roughly 5 to 10 times higher levels. So the natural scientific question is, what's the impact of this acid on these dogs? And thankfully, there is a large database on slide 14 of data from more than 100,000 dogs over nearly 60 years, in which at 3 Swiss veterinary diagnostic centers, the details of the dogs were recorded. This large database includes 241 of these dogs. And when the comparison is done, slide 15, it turns out that these dogs indeed have significantly reduced incidence of these cancers compared to other dogs of similar age and weight. This is showing that there are mechanisms in nature which can be copied in principle from one animal to another. Let me refer now on slide 16 to work that I saw presented at various conferences recently by the aging researcher, anti-aging researcher, let's say Vera Gorbanova from Rochester, New York. She explained the experiments of her lab that took the normal naked mole rat and genetically edited it so that it no longer made the same hyaluronic acid long chains. And the resulting creatures, on this picture, it shows them as being a mouse. Well, I mean, they were mouse-like. They were easily prone to cancer. The big question is, what happens if we take a normal mouse that normally lives 2 or 3 years and normally is prone to cancer, and we edit it in the same way so that it generates larger quantities of these long chain HA? The answer's on the next slide. These mice, when they are middle-aged, 2 years old, compared to the normal mice, they are fitter, they run better. In fact, they can run twice as fast, twice as far on the treadmills before becoming exhausted. They have a stronger grip, and maybe of interest, their skin is visibly smoother, their fur is visibly smoother. Critically, indeed, they have less cancer, either spontaneously arising cancer or cancer that is induced by scientists doing dreadful things to them. And lastly, there is some lifespan increase too. The actual results have not yet been published. keep watching the scientific literature or come back for further talks. Slide 18 shows this is only one of the aspects of naked mole rats that is so interesting. This is data from a company called Calico Life Sciences, which, by the way, is a member of the Google family of companies. They have used analysis of large sets of data to show several curves similar to the ones I had earlier. It shows that for humans and for mice and indeed for horses, the mortality increases over time. But for the naked mole rat, which you can see at the top, and you can also see all the curves combined onto a single chart in the middle, it doesn't become more likely to die as it gets older. It still has some chance of dying because of infectious diseases, or indeed because these rats sometimes fight each other. But as in the title of this scientific paper, these naked mole rats defy the Gompertz law by not increasing with age.